Howdy, AP PreCal. It is Miss Kosh. I am going to make my answer key to the notes. This is over 3.1, the periodic phenomenon. So AP likes to kind of look at non-trig periodic situations before jumping into trig functions. So I rewrote my notes for this year, and here we go. Okay, so a periodic relationship, and this is how AP defined it. I copied and pasted. A periodic relationship can be identified between two aspects of a context if, as the input values increase, the output values demonstrate a repeating pattern over successive equal length intervals. Okay, basically what happens is it has to have the same pattern over and over and over again, and it doesn't, and the length of that pattern doesn't change. Okay, so that the length of the pattern, and we'll talk about this more as we keep going, is called the period, and that's the word for the next, that's an O. The period of the function is the smallest possible k value such that f of x plus k equals f of x for all x in the domain. Consequently, the behavior of a periodic function is completely determined by any interval of width k. Okay, so the period of the function would be k here. I like to say, how long does it take us to do everything it's going to do? And so that's the period of the particular function. So I have given you, I created this weird little piecewise thing on Desmos, and I'm saying that this is one period of a periodic function. And so then the second period, well, notice it goes up, it goes over, it has this little semicircle, and it comes down. Okay, so that's everything that it's going to do, and it did that between 0 and 8. So the period of this function is 8. Okay, so let me get rid of the clutter. So now we're going to just kind of repeat this one more time. So I see when I go over 1, I go up 2. So here's that point. I'll just put in a few points, and I'm going to be straight along there. Go over 2, and then it's up 2. So it's kind of a little circle, then over 2. I'm kind of trying to, and sure enough, I can double check. I thought I had a period of 8, and so I should return, or I should finish the pattern when I get to 16, since it had a period of 8. So once I have those points, my students are really good at like letting Notability make the correct shape. I'm not, like, they would have a beautiful straight line. They would sometimes things will start to become a line, but I don't know how to do it like they do. Anyway, it doesn't matter. So here is the second complete period of this little periodic function. Okay, it says a portion of a periodic function f is given below. The period is blank. Okay, so different ways to think about this. I can start here at 0, and then I have half of a semicircle, and then I have a straight little piece, and then I go up, and then I go down, and then I come back into the other half. And now basically, let's see if this will work. Basically, I can take this and that, yay for Desmos, or yay for Notability. I can pick this up, and this is the pattern that keeps repeating over and over again. Okay, so how long did it take us to do everything it's going to do? We went from 0 and we got there by 5. So the period of this little function here is 5. Okay, so then the way that I want to teach this year is we have already been looking at the unit circle, and so my kids may remember that we would solve problems that I would say I would tell you to find all values of theta where, I don't know, sine of theta equals 1/2. And so since I said find all the values, sine is the y value. We went a y value of 1/2, which means we've gone up a little. And so this would be pi over 6 in this quadrant and 5 pi over 6. But then once I have everything that's coterminal to that, so then this could be 13 pi over 6, and this could be 17 pi over 6. And I can keep going and going and going. I have infinitely many coterminal angles. So when they say find all values, we would say theta is equal to pi over 6 plus 2 pi k. And then we would say 5 pi over 6 plus 2 pi k. But k, the variable k, besides being our favorite letter, the variable k has a particular meaning. If it were just any random number, that wouldn't work for us. It has to be an integer. And so we use this fancy math symbol. My kids have shortened it to Kez over the years, but it's telling us k is an element of the integers. That funny z with an extra line means integers. You may already know that r with an extra line is real numbers. There's a few of them, but the integer is with a z. Okay, so now this is, well, I'll keep this clutter. I'll just make it smaller because I think I need the space. Oh, that didn't work. Oh, I'm sorry. I could have done that later, but well, it's just not going to happen. Okay, so we're going to use a similar idea. Here was the whole point in that. What we had done before when we wanted to end up getting infinitely many answers, we would use a variable that was an integer. And so what we're going to find is that this is happening. Not only are they coterminal angles, but they also, this will become a periodic function, but we're not quite ready for that, so hang tight. So back over here, what I want to say is if we let, forgot to switch to the bin. If we let k be an element of the integers, you could use n, you could use, I wouldn't use x. That is a funny looking z, but there we go. Then we could say that this is the function f of, well, 0 plus, what was my period? My period was, I'm going to say it this way for the first time, plus 5k. So that means if f of 0, f of, when I plug in 1 for k, f of 5, f of 10, f of 15, f of 20, those are all going to be equal to, well, what's that value? That value right here is 0. So f of, and I could just have called this f of 5k, will be equal to 0. The next one, so then what happened, I curved up and around, and so at f of 1 is equal to 1. But it would also happen every time we do another complete period. Either way we go. So we could go, we could plug in, I'll show you more as we keep going, but let's write this down. F of 1 plus 5k will be equal to 1. The next point I see is here. I see f of 2 plus 5k will be equal to 1 also. F of 3, now, I mean, it's going to do this whole little shape, and I could come up with even more answers, but that would just be a little silly. F of 3 will be equal to, f of 3 plus 5k will be equal to 3. F of 4 plus 5k will be equal to, I think it made it back to positive 1. And then f of 5 right here was actually fit into this situation that we already have, so we don't need to write that one down again. And we can use this now to help us figure out these other ones. So they'll say something like, okay, here's this periodic function. Here's what it looks like. Tell me what would the value be, and they're going to give you things that don't fit on the graph, okay? So what we might do, one way to think about this, is to write out these rules, these little formulas, and then think of, okay, well, what would this one be? This would be f of, well, my period was 5, so if I do, it's 2 plus 5 times what? Well, 5 times negative 2. So this means that I've gone 2 full periods in the negative direction, and then I came back a little bit more positive by 2. Anyway, so basically what I was saying is I went, here's negative 5, then negative 10 would be, somewhere over here, and then I came back to negative 8. Anyway, we'll do a few more, and this will make a little more sense as we keep going. And, well, what do we know that f of 2 plus 5k is equal to? It's equal to 1. In particular, it would be this part right here that we're looking at over there. Okay, f of 25 would be, well, that is 5 times 5. And so this is just the scenario here where we're looking at f of 5k. And so that is equal to 0. F of 11, well, I see that this is 1 plus 5 times 2. And, well, f of 1 is equal to 1, and so there we go. The next one, 48. Well, so I can say this is 3 more than 45, which is 5 times 9, which will be equal to 3 plus whatever. This is right here. Not 3 plus whatever, but 3 plus 5 times our integer, and our integer in this case was 9, is going to be equal to, the y value was 3. The output value, they like to talk output value. Okay, I could do this last one. I could look at this as saying f of negative 1 plus 5 times negative 4, which is fine, but that doesn't really match any of the scenarios that I already created. Instead, what I might do would be to say, I mean, that's not wrong. There's nothing wrong with what we have, but instead I might say f of, let's do 5 times negative 5. That gives me negative 25, and then I would have to add 4 to that. Okay, and so then that matches this scenario right here. So this, you could use either one, and they're both going to equal 1. Okay, let me see, how much do I have? Should I make another video? Yeah. Come back, come find the next video, and I will like, subscribe, comment, all the things, and I'll make this next video in just a second. All right, go practice.